So in this video, we're going to look at working out the inverse of a 3 by 3 matrix. Now the inverse of a 3 by 3 matrix only exists if the determinant is non-zero. In other words, it's a non-singular matrix. And to find the inverse of a 3 by 3 matrix, we use elementary row operations, as opposed to with a 2 by 2 matrix, we divided the adjugate of the matrix by the determinant of the matrix. But with a 3 by 3 matrix, we can't do that. But we know by definition that if we pre or post multiply the inverse by the original matrix, then the result is the identity matrix. And so what we can do is set up an augmented matrix and start with A on the left-hand side and put the identity matrix on the right-hand side as our result. And the goal is to make the left-hand side into the identity matrix, and that will leave us with the inverse matrix on the right-hand side. So in this example, we want to find the inverse, if it exists, of matrix A, where it's 1, negative 2, 0, negative 3, 8, negative 3, 2, negative 5, 2. So the question says, find the inverse if it exists. And we know that a determinant has to not equal 0 in order for an inverse matrix to exist. So if the inverse of matrix A exists, the determinant of A cannot equal 0. So we need to work out what the determinant of A is, and we can do that by 1 multiplied by the determinant of 8, negative 3, negative 5, 2. We're going to take away negative 2 multiplied by the determinant of negative 3, 2, 2. And we're going to add on 0 multiplied by the determinant of negative 3, 8, 2, negative 5, which is obviously going to equate to 0. So that's going to give us 1 multiplied by 16 take away 15. We're going to add on 2 multiplied by negative 6 plus 6. And we're going to add on 0 at the end. And this becomes 1 plus, and negative 6 plus 6 is 0, so we get 0 plus another 0, which gives us a determinant of A of 1, and therefore an inverse exists for matrix A. And so we can go about setting up our augmented matrix, remembering that we want matrix A on the left-hand side and our resultant matrix, the identity matrix, on the right. So row 1, 1, negative 2, 0 on the left-hand side, and 1, 0, 0 on the right-hand side. Row 2 is negative 3, 8, negative 3, and 0, 1, 0 as our result. We want 2, negative 5, 2 in row 3, and our result will be 0, 0, 1. Now we need to use our elementary row operations in order to eliminate all of the elements in column 1 apart from A11. And we're going to do this using row 1 to help. So our row 1 is going to stay the same, so we'll rewrite that. Then we want to eliminate the negative 3 in A21, so we're going to take row 2 and we're going to add on 3 times row 1, and that's going to give us 0, 2, negative 3, and 3, 1, 0 on the right hand side. Then we're going to eliminate the 2 in A31, and so row 3 is going to become row 3 minus 2 row 1. So row 3 is going to become 0, negative 1, 2, negative 2, 0, 1. Now we're going to leave our first row, 1, negative 2, 0, and 1, 0, 0 on the right hand side. And we're going to rewrite row 2 as 0, 2, negative 3, and 3, 1, 0. And what we want to do now is we want to eliminate the negative 1 in A32. And we're going to do that by taking row 3 and we're going to do R2 plus 2R3. And that means row 3 is going to become 0, 0, 1 and negative 1, 1, 2. Now the next thing we want to do is we want to eliminate the negative 3 in A23. So we need to rewrite row 1 because we're not making any changes to it. So that's 1, negative 2, 0, 1, 0, 0. And to eliminate that negative 3, we're going to do row 2, and we're going to add on 3 of row 3. And that's going to give us row 2 of 0, 2, 0. And then we've got 0, 4, 6 on the right hand side. And row 3 is going to be exactly the same. So now we need to eliminate the negative 2 that is in position A12 on that row 1. And so we're going to do this by taking row 1 and adding on row 2. And that gives us 1, 0, 0, 1, 4, 6. Now we need our lead diagonal to be all 1s, so that middle element needs to be divided by 2. So we need to half all the contents of row 2, which is going to give us 0, 1, 0 and 0, 2, 3. And our row 3 elements are 0, 0, 1 and negative 1, 1, 2. And if we compare this, we've now got the identity matrix on the left-hand side and our inverse matrix on the right. So therefore, we can state that the inverse matrix of A is going to be 1, 4, 6, 0, 2, 3, and negative 1, 1, 2.